ప్రాక్టీస్ చేస్తే అంత బాగా రాస్తారు ఎగ్జామ్ లో. Yes, good evening everyone students. Welcome to online coaching for Polycet, sponsored by Jatadhara Educational Technology. Now I would like to invite Arun sir to start the session. Arun sir?
Thank you, ma'am. Yes, thank you, ma'am.
Thank you, sir.
Hello, students. Hello, everyone. Good evening. So today let's do yet another chapter from physical sciences, which is electromagnetism. All right. So let's get started. Students, we will again walk you through the theory. Then we'll go over to the questions. All right, as usual. So let's quickly walk through the theory. All right, students, here is what we have got about electromagnetism and the experiments conducted before the scientific theory was established. All right, so and this resulted in inventions like dynamo and electric motor and new technologies like radio, television, and fiber optics. All right, let's see what is magnetic field, students. Magnetic field, if we talk about a bar magnet, if I place a compass needle at certain distance, that bar magnet needle will direct in certain direction. If I remove the bar magnet, that needle will point in the north-south direction, geographic north and south. But if I keep in the presence of bar magnet, that will get influenced because of the bar magnet, which shows the presence of magnetic field. That's how we can detect the magnetic field using a compass needle. All right, and because it gets oriented in certain direction, it tells us that magnetic field has got certain direction. And also, from some other experiments, we can also conclude that magnetic field also varies with distance. So we have got two things. One is it has got direction and magnitude. Magnitude varies with distance from the bar magnet, and direction can be determined using the compass needle. And it's three-dimensional, students. Magnetic field is three-dimensional. We conduct the experiment on paper, but even if I lift the bar magnet and conduct the experiment, I can still feel the needle being deflected. All right, so it's three-dimensional. So magnetic field exists in the region surrounding a bar magnet and is characterized by strength and direction. Students, the activities మీరు demonstration చూస్తే మీకు చాలా బాగా అర్థమవుతుంది. But as of now, demonstrations we haven't done. We haven't shown you anything till now. But if you subscribe to the YouTube channel, you will soon get to know some demonstrations. మీకు చూపిస్తాము. For that, you will have to subscribe to the YouTube channel. మీకు alert వస్తుంది. All right, now let's look at the field lines. Field lines are imaginary lines, students. These curved lines at the right magnetic field lines because of a bar magnet. These arrow marks show us the field lines. Field lines are nothing but the envelope of the magnetic field vectors in space. ఇక్కడ నేను tangent draw చేస్తే అది magnetic field direction వచ్చేస్తుంది నాకు. If I draw a tangent to this field line, I'll get the direction of magnetic field. If I draw a tangent over here, I'll get the direction of the magnetic field over here. Now, if you look at this thing, if they are closely spaced, that means magnetic field intensity is more. Stronger field, they're spaced apart, then the field is weaker there. So field is strong when the lines are crowded, field is weak when they are spaced apart. Thus the field lines, field drawn is not uniform because strength and direction both change from point to point. Uniform eppudu antaru when you have got direction and magnitude remaining the same throughout the space. Then you call it uniform field. Uniform field is uniform magnetic field is impractical, students. We'll get almost uniform field in solenoid. All right, now let's look at this one. The field is said to be non-uniform when any one of the characteristics of the field, that is strength or direction, changes from point to point. Similarly, if the field is uniform, both strength and direction are constant throughout the field. All right, here is a field pattern of uniform field. Look at this. Spacing is uniform and the direction is constant. Direction is from left to right and the spacing is uniform. Spacing uniform kaakunte, then it is definitely a non-uniform magnetic field. But if I have to represent a uniform magnetic field, this is the only representation, students. Not just magnetic field, electric field kuda uniform చూపియాలంటే ఇలానే చూపిస్తారు. Now, let's talk about flux. The number of lines passing through the plane of area A perpendicular to the field is called magnetic flux and is denoted by phi, phi phi. I've got an area like this. This is the field lines from here, this point to this point, this way, towards right. And this is the area. If field lines are piercing like this, then there is flux through this area. All right. And if I orient this, they are piercing, but the flux changes because orientation is changing. If I make this parallel to the field lines are grazing, so no flux to the area. So it depends on the angle, area, and the magnetic field. So 3 factors. All right, look at this. So magnetic field is nothing but the ratio of flux passing through the plane perpendicular to the field and area of the plane is called the magnetic flux density. What is density per unit area? So magnetic flux density is equal to magnetic flux per unit area. So B is equal to phi by A or phi is equal to B times A. So units of magnetic flux density is Weber per meter square. It is also called as Tesla. Just a second, students. Yeah. So where are we? Yeah, over here. Now look at this pattern. All right. Now I've got a solenoid. What is a solenoid? If the current, this is spiral coil, spiral wire, if I pass current through it, it behaves like a bar magnet. Why do we say it behaves like a bar magnet? Because field lines are identical, almost identical. So we say we got north and south for the bar magnet. Similarly, we got north and south for the solenoid. But in between the solenoid, if I have got a long solenoid, in between the solenoid over here, where the density is intense, it is almost uniform. It's not uniform. It's almost uniform. మీరు ఇంటర్మీడియట్ లో డిరైవ్ చేస్తారు స్టూడెంట్స్. ఆల్రైట్, క్యాలిక్యులస్ యూస్ చేసి డిరైవ్ చేస్తారు. బట్ యాజ్ ఆఫ్ నౌ యూ జస్ట్ రిమెంబర్ దట్ ఇన్సైడ్ ద solenoid, long is very important. Long solenoid, I've got a uniform intensity, uniform magnetic field density at near the center of the solenoid. So one end of the solenoid behaves like a north pole, and the other behaves like a south pole. Look at the field line, students. Outside, the field lines are from north to south, but whereas inside they are from south to north. And they are loops. Magnetic field lines are always closed loops, students. Magnetic field lines are always closed loops. You will never have an open loop for a magnetic field. Which symbol you are talking about? Flux symbol is phi, phi phi. All right, let's go to the next point. Now, we'll study uniform magnetic fields itself. All right, studying non-uniform magnetic fields requires vector calculus, but we study uniform magnetic fields, wherein if I project a charge, that charge is acted upon by a force. All right. So moving charges, magnetic field exerts force on moving charges, and this force is called magnetic force. But it doesn't exert on in any situation. It exerts force except when the charge particle is parallel or anti-parallel to the magnetic field. If let's say the magnetic field is towards right, this is the direction of the magnetic field. All right. And then I've got, this is the direction of the projection. If I project the particle in this direction, then the force is 0. Or if I project the particle in this direction, the force is 0. If the magnetic field line and the velocity are parallel or anti-parallel, then the force is 0. In all other cases, you will have force. But when they are perpendicular to each other, velocity and magnetic field are perpendicular to each other, the force is F is equal to QBB. But if they are not perpendicular, some random angle, it is QBB sine theta. All right. So it is 0 when parallel, 0 when anti-parallel, F is equal to QBB when perpendicular. When making an angle theta with the magnetic field, some theta, it is QBB sine theta. When theta becomes 90, sine 90 becomes 1, I'll get QBB. All right. When theta becomes 0, sine 0 is 0, I'll get QBB into 0, which is 0. So F is equal to QBB sine theta is a more generic expression for the force acting on a charged particle in a magnetic field. Yeah, over here, look at this. F is equal to QBB sine theta. That's what you're talking about. Now, you have to accept that you'll get the proof in intermediate that if I project a particle perpendicular to the velocity, perpendicular to the magnetic field, it goes in a circular path. All right. It goes in a circular path like this. And this radius of the circular path is given by mv by qb. All right. mv by qb is the radius of the circular path. Okay. And now, similarly, because current carrying conductor is nothing but the charge in motion, the current is nothing but charge in motion. If a charge in motion experiences force, a current carrying conductor will also experience force, right? And that force is given by ILB sine theta. All right. So QEB sine theta for a particle, charged particle moving in a magnetic field. But for a current carrying conductor is ILB sine theta, where I is the current in the conductor, L is the length of the conductor, and B is the magnetic field, and theta is the angle between current direction and the magnetic field. Direction of the current and the magnetic field. All right, and there's an important point here. In electric motors, electric energy is converted into mechanical energy. All right, it's a very important point. Repeatedly asked. Let's see what is electromagnetic induction now. Now, Faraday's law states whenever there is a continuous change of magnetic flux linked with a closed coil, a current is generated in the coil. That is Faraday's law. All right, mathematically, it can be given by change in flux by time taken. Delta T, delta phi, delta T, delta phi by delta T. Now, look at this. We get the induced current. See, we said current is generated in the coil. Now, when there is a coil, let's say this is a coil. All right, let's say this is the coil. If this is the coil, if current is clockwise or anti-clockwise, there are two possibilities. It could be clockwise or anti-clockwise when seen from your side. If it is clockwise from your side, it's anti-clockwise from my side. It's clockwise from my side, anti-clockwise from your side. But there are two possibilities, clockwise or anti-clockwise. That direction is determined by Lenz law. Magnitude of EMF is given by Faraday's law, but the direction is given by Lenz law, which states induced current will appear in such a way that such a direction that it opposes the change in flux in the coil. All right, if there is a change in flux, it opposes a change in flux. All right, students, important points are covered. Shall we go for the questions now? Are you all ready for questions? Type yes in the chat box. All right. Good, good, good. All right, so many yeses. All right, so let's get started. The first question. Units of magnetic flux in CGS system are magnetic flux in CGS system. Yes, yes, yes. Let's look at the key. Yes, absolutely right, students. Under correct చెప్పారు. Almost everyone has told. Yeah, second is Weber per Tesla. Third is Tesla, which is magnetic field, students, not magnetic flux. Magnetic flux density. So one is absolutely right, students. Gayatri, Taruni, Bhavana, Ria, Angel, Sai Vardhan. Yeah, good, excellent. Here's the next one. Units of magnetic flux in SI system are magnetic flux density or magnetic flux? Magnetic flux. Okay. Okay, Angel says 3, Ria says 3, Sharon says 3. Let's look at the answer. 3 is absolutely right, students. Taruni says 3, Gayatri says 3, Vishwant, Gautami, Saivardhan. All right, good. Let's look at the next one. Formula for magnetic flux density. You've seen the formula just now. B is equal to 5 by A, BLV sine theta, 5 by L, none. Consistent response, excellent. 2 is absolutely right, students. Students, ఒకవేళ తప్పుపోతే that's okay. మీరు correct చేసుకోండి. The whole intention behind the practice session is you commit a mistake, you correct yourself. Attempt, commit a mistake, correct yourself. Look at this one, students. CGS unit of magnetic flux density are CGS unit of magnetic flux density. Be careful. He's saying CGS unit, students. I'll give you 5 more seconds. Five, 4, 3, 2, 1. All right, let's look at the key. It's Gauss. Gauss, students. Let me see who all are right. None of you are right. Students, it's Gauss. Okay, make a note of it. None of you are right. Yeah, Ria, Mohan, and Taruni. Right. Rest of all, please correct yourself. That's okay. Learn from your mistake. SI unit of magnetic flux density are Weber, Weber per meter square, Tesla, 2 and 3. Tesla and Weber per meter square. Okay, 4, 4, 4. Students, direct your answers to me. Me answers now send change it. Jet Arun ki send change. Otherwise, I'll presume that you're not participating. Yes, Riya, Sandeep, Bhavna, Pranita, Vishwant, Dikshita, all are right. Good. Let's look at the key. Yes, 2 and 3, Weber per meter square, and that is also given as name Tesla in honor of Nicholas Tesla. All right, let's look at the next one. Here, 1 Tesla is how many Gauss? 10 square, 10 power 4, 10 power minus 4, 10 power minus 2. All right. Okay, confusion. That's okay. Please correct yourself. Priya is correct. Who else is here? Saivardhan, Varun, Tej, Gautami. I'll give you 5 more seconds, students. I'm waiting for other answers. There are students who are not participating yet. Okay. All right. 2 is absolutely right, students. 2 is absolutely right. It's 1 Tesla is 10 power 4 Gauss, or 1 Gauss is 10 power minus 4 Tesla. Dash current has some frequency. AC, DC, AC, and DC. What is the fourth option? Induced. Which current has got frequency? When do you say current has a frequency? Does a DC current have constant DC, presuming? Does DC have frequency? We don't talk of frequency for a DC, right? So, Varun, Tej, Agnivesh, yes. Go ahead, go ahead. Gayatri, Riya, Vishwant, good. Bhavna, Saivardhan. No, Saivardhan, think again. Bhavna. Right, let's look at the key. It's AC, students, alternating current. All right. Again, similar question. Frequency of the direct current is 0, 90, 240, any number may exist. Frequency of a direct current. Okay, Vishwant is right. Riya, Saivardhan, Mohan, Jessica, Bhavna, Gayatri, yes. Right, right, right. Excellent. 0. Frequency of direct current is 0. Doesn't modulate at all. This sentence we have seen, I told you this is an important sentence. Motor converts dash energy to dash energy. Mechanical to electrical, electrical to light, electrical to mechanical, all the above. Yes, good, consistent response. Varun Tej, Sandeep. Yeah. Priya, Bhavna, Gayatri. Yes, correct. Saivardhan, Raghu. Mohan, think again. Gautami, right, right, right. Good. Yes. Okay, Riya and Sharath. Sharan and Pranati, all right, together. So 2 students are attending together, Sharan and Pranati. All right, good, good, good. I appreciate that. All right, so let's look at the key. Three is absolutely right, students. Sharan, you had a confusion. Sharan and Pranati, you had a confusion. It's 3. 3 is absolutely right. But I appreciate that you have attempted. Make an attempt even if you have confusion, students. Solenoid is a dash-shaped coil. Circular, rectangular, spiral, elliptical. You have seen a solenoid. Is it circular, rectangular, spiral, or elliptical? No, elliptical is we haven't come across like any geometry like elliptical students. Ellipse మనం చూడలేదు 10th class syllabus లో, except we have seen in Sommerfeld orbits, atomic model లో. All right, so it could be spiral, rectangular, or circular. All right, Riya says spiral, Bhavana says spiral, Jessica says spiral. Okay, good. Mohan says spiral. Okay. Let's look at the key. Spiral is correct, students. Good. Almost consistent response, but there were wrong answers as well. Please correct yourself. All right. Let's go for the next one. Solenoid works as dash when current passes through it. We get an identical magnetic field as that of bar magnet, horseshoe, transformer, or none. Yes, Bhavna, Gayatri, Gautami. Yes, Riya. Right, Saivardhan. Excellent. But there are wrong answers as well. See, wrong answers is what I'm worried about. మీరు కరెక్ట్ చేసుకుంటున్నారా లేరా నాకు భయం ఉంది. Please correct yourself, because the whole intention behind this session is to benefit you in such a way that you can perform well in the exam. ఎగ్జామ్ బాగా ఫేస్ చేయాలంటే ప్రాక్టీస్ సెషన్లో కరెక్ట్ చేసుకోవాలి, తప్పుపోతే కరెక్ట్ చేసుకోవాలి. బార్ మ్యాగ్నెట్ స్టూడెంట్స్, బార్ మ్యాగ్నెట్ లాగానే కనిపిస్తుంది. Solenoid's magnetic field and bar magnetic field will seem almost identical. That's why we also say solenoid లో there are loops, bar magnet లో కూడా loops ఉంటాయని అప్పుడు అందుకే చెప్తాం మనం. Dash works on the rule of magnetic induction. Tape recorder, induction stove, ATM machine, all the above. Oh, consistent response. Good. Good. Everyone. Not even one is wrong. Good. Excellent. Your factual knowledge is very good, students. మీకు అప్లికేషన్స్ అంటే చాలా ఇష్టం అనుకుంటా, అందుకే మీరు అప్లికేషన్ క్వశ్చన్ వస్తే చాలా బాగా గుర్తు పెట్టుకుంటున్నారు. ఆల్ రైట్, ఆల్ ది అబవ్, అబ్సల్యూట్లీ రైట్. Dash converts mechanical energy to electrical energy. Motor, AC dynamo, DC generator, 2 and 3. Mm-hmm. 4, 3, 3, 1. Sharon and Pranati, okay. It's AC dynamo and DC generator, students. Electric to mechanical is, we have seen motor, but the converse, AC dynamo and DC generator convert mechanical energy to electrical energy. Look at this one. The relation between the direction of dash and dash is established in Maxwell's Cox-Through rule or law. Electric current and magnetic field, induced current, resultant magnetic field, quantity of current and magnetic flux, induced voltage and frequency. Oh. Okay. Jessica, Bhavna, Gayatri, Saivardhan, Bhavna, Saivardhan. How many times did you answer? All right, I got the point that you answered. Vishwant, okay. Vishwant, 3. Okay, think again. Chautami, Jessica, Sri, Yes, these are all right, students. So first one is absolutely right. Corkscrew rule, electric current and magnetic field. Electromagnetic induction was proposed by Oersted, Faraday, Weber, Ewing. Okay. I'm getting a consistent response for this one. All right. Wrong response as well. Students, electromagnetic induction was proposed by Faraday, not Weber. All right. One wrong response I got. Cyberthan, please correct yourself. All right. You have been answering very well till now, but you went wrong over here. Please correct yourself. Look at this one. Dash law gives us negative sign in E is equal to minus d phi by dt. So which law gives us the talks about the negative sign? The significance of negative sign is given by Oersted, Faraday, Lenz, Weber. Which law? Oersted law, Faraday's law, Lenz law, Weber law. There is something called Weber law. Negative sign is a qualitative law given by Lenz. All right, so Lenz law is a qualitative law in physics, which has got analogous laws in chemistry as well. Chemistry lo kuda Lenz law laantide inkoka law vastundi. Le Chatelier's principle ani. All right, that we'll talk about it later, but let's go to the next one. The force experienced by a conductor having I kept in uniform magnetic field is students, the question is incomplete actually. This question, understand one thing from this question. He said I kept in the uniform magnetic field, but direction cheppaledu. If he says perpendicular, then it's ILB sine theta. But if he says parallel to the magnetic field, then F is 0. All right. So this question is actually incomplete, students. Data is not sufficient actually. Answer cheppalante data is sufficient. Yes, you'll have two possibilities. In fact, 3 and 4 options are same. 1 and 2 options are same. So Agnivesh is right. 1 or 3 it could be, but depending on the situation. If the that conductor is parallel to the magnetic field, then the force is 3 or 4. If it is perpendicular, then its force is 1 and 2. All right, so it's ILB sine 90 provided the angle is 90 degrees. If it is 90 degrees, sine 90 is 1, that's something called ILB. Okay, if a conductor with 3 ampere current kept in a 0.3 Tesla magnetic field density making an angle 30 degrees is 27 Newton, 0.9 by 2 Newton, 30.9 Newton, depends on the length of the conductor. Length village students. Current icharu, magnetic field icharu, angle icharu. So F is equal to ILB sine theta lo, L ivalledu. L is supposed to be given, right? ILB sine theta, theta is given, B is given, I is given. So what do you think is right? Yes, Sharon is right, Raghu is right, Saivardhan is right. What about other students? Quickly answer. Priya is right, Bhavna is right. Saivardhan, right. All right. Kumari. Others, I don't know how you're getting 30.9 students. Hello, 30.9. Yes, it exactly depends on the conductor, length of the conductor as well. Length of the conductor is below, so data is not sufficient. For me to calculate force, data is not sufficient. So that data, insufficient data, is nothing but length of the conductor. So it definitely depends on length of the conductor. It's off, right off. All right. F is equal to ILB by 2, then the angle between the conductor and the magnetic field direction is, look at this, ILB sine theta. Sine theta is nothing but 1 by 2. If sine theta is 1 by 2, theta is, yes, Riya, Gayatri, Saivardhan, Kumari, Varun Tej. All right, let me show the key. It is 30 degrees, students. ILB sine theta. Sine theta is 1 by 2. So theta is 30 degrees. Simple. All right. Here's the next question. If the angle between conductor and magnetic field is 45 degrees, then the force on the conductor is ILB sine theta. Theta is 45. Substitute theta is 45 in the equation. Yes, option 3. Riya, Bhavna, right? Good. All right. Consistent response this time. Is 3 absolutely right. Which of the following does not work on electromagnetic induction principle? Transformer, tape recorder, ATM card, none. We have seen this question before. Only thing is it is asking does not work. Yes, Gayatri, Riya, Bhavna, Varun Tej, Raghu, correct. Excellent. Excellent energy, students. Shri. All right, let's get the key. It's none, students. 1, 2, and 3 definitely work on electromagnetic induction. All right. So 1, 2, and 3 definitely work on electromagnetic induction. So what doesn't work is definitely not 1, 2, and 3. It's 4. Dash is an imaginary line that which is equidistant from two poles and passes through the center of the bar magnet. Axial line, equatorial line, line of force, all the above. So bar magnet unte, that line which is passing through the center and equidistant from both the poles, two poles. Yes, correct, good. Saivardhan, Riya, Agnivesh, you have a confusion, that's okay, but I appreciate you have attempted. Varun Tej. See, you cannot have axial and equatorial together. That's contradictory. So all the above is ruled out because you cannot have equal the axial and equatorial lines together. If it is axial is this way along the bar magnet, equatorial is perpendicular to the bar magnet. So all the above is ruled out, students. Equatorial line is this way, axial line is this way. Equatorial is right. All right, let's look at the next one. Magnetic lines of force move from dash pole to the dash pole, north to south, south to north, center to south. We are talking about magnetic field lines move from dash pole to dash pole. In the context of bar magnet, external to the bar magnet, outside the bar magnet. Yes. Kumari, Bhavna, Saivardhan, Jessica, Riya. This is in context of bar magnet, outside the bar magnet, students. Gayatri, Varun Tej, Gautami. Okay. Yes, north to south. The magnetic field induction is 0 at dash of the bar magnet. Poles, center, neutral points, all the above. Kumari, outside is north to south, inside is south to north. Correct yourself, Kumari. It's north to south, outside, south to north, inside the bar magnet. All right, good. Yeah, that's okay. That's okay, Kumari. Mistakes are okay. Absolutely okay. As long as you correct yourself. Mistake schedule, mistake aim, that's okay. Okay, so now neutral point, center, poles, all the above. Magnetic field induction is 0. It's neutral point, students. Neutral and antaru. Zero field neutral point antaru mana. A field aina, magnetic field aina, gravitational field aina, electric field aina, zero field point ki neutral points antaru. The magnetic lines of force are closed, open, circles, ellipses. Closed, open, circle, ellipses. We are talking in general. We are not talking for a long conductor. For a long conductor, it's circles. Ellipses for some particular configuration. But in general, they are closed. Excellent. Everyone is right. In uniform magnetic field, dash is constant. Magnetic field induction, magnetic field density, field direction, all the above. Supposed to be magnetic flux density, students. All right, in a uniform magnetic field, dash is constant. Field direction is definitely constant. Good. Let's see. All the above, students. All right, let's go for the next one. Here, relation between flux, field induction, and area of the loop and angle theta is phi is equal to BA cos theta, phi by A secant theta is equal to B. Just manipulating, students. Left cross multiply cheste cos theta secant theta rastunaru. So A is equal to B phi by B cos theta. That comes from 1 itself. So or is it all the above? Be careful. Just look at the options. They are all same options. Yes. Yes. Good. 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 Everyone is right this time again. Students, second option, first option. Okay, students. Second, 1, 2, and 3 are same. I'm just cross multiplying cos theta from here to there and then writing cos theta as secant theta. Yes, good. 4 is correct. Good. The direction of lines of force in the inner side of a solenoid is north to south, south to north, east to west, none. Inside the solenoid. Yes, Kumari is right, Gayatri is right, Bhavana is right, Agnivesh is right, Varun Tej is right, Riya is right. Outside the field, Gautami, then what is outside the field? Yes, Saivardhan is right. There is no east-west direction over here. That's just a diversion. Gautami is right. Okay, Sri has changed the answer, but think again, Sri. Think again, think again. You're very close. Think again. It's south to north. All right. Inside south to north, outside is north to south. Oh, look at this. Next question is outer side of the solenoid. We just talked about it. I just told you the answer. North to south, south to north, east to west, none. The direction of lines of force in the outer side of the solenoid is yes. Now I got consistent response. Excellent, students. You are correcting yourself. Vishwant, outside the solenoid, not inside. ఇప్పుడే ఇన్సైడ్ చూసాము ఇన్సైడ్ సౌత్ టు నార్త్ ఉండే అవుట్సైడ్ ఇట్ బి నార్త్ టు సౌత్ ఆల్రైట్ విశ్వంత్ యా గుడ్ toroid is nothing but dash shaped solenoid, circular, elliptical, rectangular, square. toroid కూడా ఇంటర్మీడియట్ లో డీటెయిల్ గా ఉంటుంది స్టూడెంట్స్. You will in fact derive the magnetic field inside the toroid. All right, let's get the answer. It's circular. Let's go for the next one. If Q is a charged particle moving with speed v in the magnetic field, then the force on this particle is QVB sin theta, cos theta, secant theta. Again, in more general sense, students, in more general sense, it is QVB sin theta, QVB cos theta, QVB secant theta. Yes, Riya is right, Gayatri is right. Agnivesh, QVB is a special case of QVB sin theta, students. అది పర్పెండిక్యులర్ అని మెన్షన్ చేస్తే QVB, పర్పెండిక్యులర్ అని మెన్షన్ చేయలేదు. So we are talking in a generic sense. Yes, two. Good. Okay. Yes, everyone is right. Except one or two. Yes, students. Two is absolutely right. Because sin theta is supposed to be mentioned actually to be more exact. But he hasn't mentioned that the particle is moving perpendicular to the magnetic field. If it were moving perpendicular to the magnetic field, then QVB is right. But in more general sense, QVB sin theta is right. Where theta is the angle between velocity vector, velocity, and magnetic field. If a force experienced by charged particle is 0, then the angle is 90, 0, 30, 60 degrees. We talked about this. Sin theta is 0. So sin 0 is 0. QVB sin theta, right? Yes, Varun Tej, Bhavna, Gayatri, Riya. Gautami. All right, I'll go a little quicker, students, because we have got math session after this. It is 0, right? I told you, if it is parallel or anti-parallel, force is 0. If velocity is parallel to B or anti-parallel to B, force is 0. Or in other words, sin 0 is 0, sin 180 is 0. Okay, this formula we have seen in the theory. Charged particle Q having mass m is moving with speed v in magnetic induction B, then the radius is, it moves in a circular path whose radius is given by mv by qb, mq by bv, mb by qv, none. Bhavna is right. Ria is right. Kumari is right. Kumari has taken the pain of typing the whole answer. I appreciate that. But you could just type the key number. That would suffice. That would be sufficient. All right. Gayatri is right. Saivardhan is right. No, Kumari, I appreciate that. That's okay. Good. Saivardhan is right. Let's look at the key. Yes. 2 is absolutely right. MB by QB. This derivation is beautiful derivation, students. Intermediate లో వస్తుంది circular motion ఇంకా magnetic field లో చాలా బాగుంటుంది. And we'll see some animations also when we do this chapter. 4 amperes current is in 1 meter length wire is experienced 4 Newton force. So the conductor is in dash induction field. 4 Tesla, 1 Gauss, 1 Tesla, 0.1 Tesla. So to find out the magnetic field, force is given. F is equal to ILB. Okay, okay. Seems like you have worked it out. That's okay, good. ILB. Excellent. That's right. 3 is right. 3 is absolutely right, students. 1 Tesla. In an AC generator, the direction of current changes because of external magnet, carbon brushes, slip rings, all the above. This AC generator mechanism is what you have to understand, students. మీరు activity or in చూసే ఉంటారు మీరు textbook లో. Okay, let's go with the key. Yes, 3. 3 is right, students. This is, you will have to understand the mechanism of the AC generator. All right. So unless you see the mechanism, some animation about it, some animation of AC generator, then you will be better able to remember such things. All right. Anyways, speed of the motor depends on number of turnings, area of armature, electric current, all the above. Okay. Yes. Kumari, Ria. Who else? Gautami. Bhavana. Yes. Saivardhan. Sandeep. Kumari. Bhavana. Varun Tej. Gayatri. Raghu. You're all right. All the above. Look at this question, students. With this, we'll conclude physics. We'll move on to mathematics. Look at this question. Interesting question. This curve shows the relation between flux and time t, phi b and time t. At which time interval EMF is not induced in the loop. Induced EMF ఎప్పుడు ఉండదు. 2 to 5 seconds, 4 to 5 seconds, 5 to 7 seconds, 1 and 3. Notice the graph carefully, students. Graphical analysis is one of the most important aspects of physics. If you are good at graphs, you will rule in physics. We'll do some part of graphical analysis in bridge course, students. Graphical analysis చేద్దాము bridge course లో. You'll understand how to deal with graphs, how to derive graphs, how to get the parent graph, how to get derived graphs, applications, కొన్ని graphs analysis చేద్దాము in bridge course. Yes. So students carefully understand this graph. చూడండి, ఫ్లక్స్ ఎప్పుడు చేంజ్ కావట్లేదు, 2 to 4 చేంజ్ కావట్లేదు, 5 to 7 చేంజ్ కావట్లేదు. Only when there is change in flux, you'll have induced EMF. When there is no change of flux, no induced EMF. So 2 to 4 change కావట్లేదు, flux is constant. 5 to 7 కావట్లేదు, flux is constant. So EMF would be 0 between 2 to 4 and 5 to 7. That's it. Ria, you're absolutely right. Others have chosen option 3, that's correct, but option 1 is also right. It's not 2 to 5. Yeah, Sony's, oh, I'm sorry. You're right. 2 to 5. All right. 2 to 4 and 5 to 7. So option 3 is right. Option 3 is absolutely right, students. Yes. Ria, that's 2 to 4 and 5 to 7. That's absolutely right. Good. Excellent. All right. Yes, Saivadan, that's right. Let's look at the key then. Students, the 1 and 3 ఎందుకు వచ్చారంటే, here it is supposed to be 2 to 4 ఇక్కడ. Typing mistake, typo, that's a typo by the typist. That's okay. But understand the point that 2 to 4 నుంచి ఇంకా 5 to 7 నుంచి flux is constant and therefore EMF is 0. All right. You understood the point, right? And your answer is absolutely right. For the given options, what you have answered is absolutely right, students. Gayatri, many. Gayatri, Riya, Bhavna, Kumari, yes. Gautami, you're all right. Okay, this is the last question. We'll go to mathematics after this. In a coil, magnetic flux changes from 4 to 6 Webers and induces EMF of 2 volts. If the flux moves from 6 Webers to 4 Webers, EMF would be 0, 2V, 2 volts decreases, 2 volts increases, 2 volts in opposite direction. Quickly answer the students. We don't have time. Mathematics is coming up. Madam is waiting for you all. Yes, Vishwant, that's right. 4 to 5. Okay, Vishwant, I'll just come back to your answer. Come back to your question in a minute. Vishwant, wait for a minute. What you have said is right, Vishwant. Wait for a minute. Let's conclude this question. Yes, 4 is absolutely right, students. Now, what Vishwant has to say is 4 to 5 దగ్గర bent ఉంది. 4 to 5 decreasing. So how can it be 2 to 5? It cannot be 2 to 5. It has to be 2 to 4 and 5 to 7. This option is wrong. What you have mentioned is 3 is right. All right. Is it clear, Vishwant? All right, let's go for the next one. Dash pole character is formed on a coil when north pole of a bar magnet approaches it. South pole, north pole, 1 or 2, 1 and 2. I have a bar magnet coil. If I approach this coil, this approaching north pole is approaching, flux is increasing. You'll have north or south. It cannot be 1 or 2, student. It has to be one. I mean, either south or north. It cannot be third option and fourth option. But it is as seen from the bar magnet. All right, presume it is seen from bar magnet. It is south, students. All right, students, let's continue with maths. Let's stop physics over here. I hope things are clear. We'll continue with maths now. All right, just give me a second, students. All right, students, let me just share the screen. And over here, we have got progressions today. All right, in math, let's do progressions. Are you all ready for maths? Students, direct your answers to me, Jatadhara. We're going to continue with math and progressions in math. All right, because you've got only 25 minutes to go. Here's the first question, students. How many terms of AP are needed to obtain the sum minus 25? Make an attempt, students. Don't go for a wild guess. I'll give you 10 more seconds for you to work out. It's 5 or 20 students. Sai Vardhan is right. Oh, students, okay, still answers are coming in. All right, all right. All right, answers are still coming in. Sorry. So Riya, Gayatri, Vishwant, Varun Tej, Sai Vardhan. All right, let's go for the next one. Here, pretty simple one. The common difference of the AP 13, 8, 3, minus 2, so on is, what's the common difference? 5, 10, minus 4, minus 5. Yes, Gayatri is right. Sai Vardhan is right. Yeah, Bhavna, Riya. Yes, Riya, that's right. Sharon and Pranati are right. Varun Tej is right, all right. Vishwant is right. Excellent. But there are students who have gone wrong. One class of students should only 1 5 only, but here AP difference is -5, right? Because 13, then you subtract 5, we'll get 8. Subtract 5, we'll get 3. Subtract 5, we'll get -2. Subtract 5, we'll get -7, -12, and so on. All right. Nth term, AN in AP is right. Hartik. Oh, everyone is typing it as 4. Good. All right. Excellent, consistent response. Good at progression, seems like that. All right. Let's go for the next one. Yes, Kumari, that's right. Appreciate the effort. All right, here. The sum of natural numbers from 1 to 100 is 4050, 10,100, 55, 5050, 5050. Sum of natural numbers from 1 to 100. Hmm. Riya is right. Bhavna is right. Who else? Yeah, Bhavna, Riya, Kumari, Varun Tej, Sharon and Pranati. Please think again. Some wrong in your calculations. Sai Vardhan, it is not 1 to 10, it is 1 to 100. Yes, Sharan and Praniti are now right. Good. Vishwant is right. Gayatri is right. Excellent. Students, please text your answers to me. Direct your answers to me. Jet Arun. Bajasthana and the progressions. Seems like you're directing your answers to someone else. Yeah, you will receive the attendance form. Don't worry. Let's continue with the session. You'll receive the attendance form. The first term of an AP is -1 and the common difference is -3. Then the 12th term is first term of an AP is -1, the common difference is -3, then 12th term is all right. Okay, Ria, Bhavna. All right, good. Seems like you're working out. That's why you're taking time to respond. That's okay. Take 10 more seconds. Yes, I'm now getting the responses. Good. Yes, Sharon, Pranati, good. Yes, -34 students. 12th term is -34. Good, excellent. A7 of the series 1, -1/2, 1/4, so on. All right. So where am I? Uh, Agnivesh, if you get 1 or 2, that means some calculation is wrong. Careful with the calculation, you'll get the right answer. Yes, one is absolutely right, students. But then Sharon Pranati, Saivardhan, Shriya, yes. Oh, I should have waited for some more time. Answers are pouring in. But good that you're all making an attempt, working it out, and then answering. Sum of first 50 even number students. First 50 even numbers is 1250, 2550, 1275, 2275. Varun Tej says, okay. Okay, Sharon and Pranati say 4. Gayatri says 2. Yes, 2 is absolutely right, students. Going a little faster. Cyberden is right. I'm sorry. Okay, look at this. The nth sum of the series 1 into 3 plus 3 into 5 plus 5 into 7 plus so on. So next would be 7 into 9. And then you'll have 9 into 11, so on, is n into n plus 2, n into n plus 5, 2n minus 1 into 2n plus 1, 2n into 2n minus 1. Take it as a test, students. Test laga cheyandi. Go slow, go strong. You won't be wrong. Exam laga rayandi. Use pen and paper, work it out, and then tell me the answer. Okay, I'll give you some 30 seconds to work it out. Answers are now pouring in. All right, work it out, students. I'll give you 30 more seconds. Students, attendance form link పంపించాను. Please fill the form.
Yes, sir, your video has been stuck. Arun, sir? Sir, your video has been stuck. Yes, students, please wait. I think there is some technical issue. I hope all of you are able to see the screen. Which question? Yes. Yes, students, direct your answers to me. Yes, 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 three. Very good, students, very good. We shall see the answer. Yes, it is option 3, that is 2n minus 1 into 2n plus 1. Let us move to the next question. The sum of first 20 odd numbers is. Yes, next question. The sum of first 20 odd numbers is. Yes, okay. Few students are saying it as option 3. No, yes, please do it, students, please do it. Yes, Gayatri, she's saying it as 1. Bhavana, 3. Yes, we will check. We will check the answer. We will check the answer. I hope you students are doing it on a paper. Yes, I'm getting the answers, different answers. Yes, so many are saying it as 1. Okay, we shall see the answer. Yes, absolutely, it is option 1, students. That is 400. The sum of first 20 odd numbers is 400. Very good. Let us move to the next question. Summation of 1 is equal to. Yes, summation of 1 is equal to. Yes, summation of 1 is equal to. You can't give me the options as 1 or 2, Avignesh. ఏదైనా ఒక ఆన్సర్ చెప్పండి. Yes, I'm getting different answers, 2 and 1. Yes, so many are answering it as 2. We shall check it. We shall check it. We shall check the answer within few minutes, few seconds. Yes, it is option 3. Summation of 1 is equals to n. So please remember, summation of 1 is equals to n. Let us move to the next question. If A, B, C are in AP, then A plus C is equal to. Please do it. If A, B, C are in AP, arithmetic progression, then A plus C is equal to. Yes. Very good, very good. So many of you are sending me the right answers. Very good, students. Yes, it is obviously option 2, that is 2B. If A, B, C are an arithmetic progression, then A plus C is equals to 2B. Let us move to the next question. If x minus 1, comma x plus 3, comma 3x minus 1 are in arithmetic progression, then x is equal to. Yes, we have moved to the next question. If x minus 1, x plus 3, 3x minus 1 are in arithmetic progression, then x is equal to. No, it is not 1. Avignesh, please check your answer. Good. Gayatri, good. Saivardhan, yes. Yasin, please check your answer. Yes, Vishwan, good. Very good. Yes, Riya Nayak. Yes, you're right. Bhavana, please check your answer. Agnivesh, please check. Yes, it is option 4. Option 4. So x is equal to 4. Yes, let us move to the next question. Common ratio of GP 1, comma minus 1 by 2, comma 1 by 4 is. Common ratio of GP. It is just T2 by T1. Right? 1 by 4 by minus 1 by 2. Sorry, minus 1 by 2 by 1. Yes, very good. Very good, students. So many of you are giving the right answers. Agnivesh have said the formula even. But also you are giving me the options 3 or 4. Any one answer? Yes, Riya Nayak. Yes, Bhavana, please check. Yes, it is option 4. That is minus 1 by 2. Let us move to the next question. The sum of the terms 1, 2, 3, 4, so on n is. The sum of the terms 1, 2, 3, 4, so on n is. The generalized expression you have to give. Yes? Very good, very good, very good. I'm seeing most of you are giving me the right answer. Most of you are giving me the right answer. Very good. Yes, yes, Riya Nayak. Yes, Bhavana, you're right. Yes, Saivardhan, Sandeep. Yes, you're giving me the right answer. Vishwan, please check. Saivardhan, please check your answer. It is not option 1 or 3. Yes, Agnivesh, you're right. Saivardhan, yes, now you are in the right track. Yes, very good, very good. Gayatri, it is not 4. Yes, it is option 2. That is the sum of the terms 1, 2, 3, 4, so on, n is n into n plus 1 by 2. Yes, students, with this question, we will end today's class. Again, tomorrow we will be having class at 7:30 p.m. Don't miss the session. And take a second and subscribe to our channel, Jatadhara Educational Technology. If you have any queries, you can message to 964-2215-226. Bye everyone. Meet you again tomorrow at 7:30 p.m. Please join 5 minutes before itself. Okay. By 7:25, please try to join. Okay. Bye everyone. And don't forget to subscribe our channel, Jatadhara Educational Technology.